Good morning, dear participants. Welcome to the last and concluding day of this online FDP on Internet of Things. So I request all the participants kindly join your hands for the Punjabi University Dhuni. Thank you so much. So we are happily reaching to the 5th day, that is concluding day of online ATAL-FDP. So very soon at 10, we will start the quiz. Am I audible to all of you?
Yes, ma'am.
Okay, thank you so much. And my screen is visible to all of you?
Yes, ma'am.
Okay, thank you so much. I have shared the link in the chat box for the quiz. Please open the link and start doing. There are 40 questions and all questions are compulsory. 1 marks each. So anybody opened the link, please give me the confirmation that it is working.
Working, ma'am?
Yes, ma'am. We have opened.
Okay, okay. Thank you. Thank you so much. MD shared the link.
मैडम टेस्ट टाइमिंग कितना है? How much time?
1 hour, sir. 1 hour.
Okay, madam. Thank you.
To that you are here, and our participants as well as me are be honored to listen. You are a great personality. Thank you so much, sir. So over to you. And now, sir, you can share your screen with us.
जी Is it visible?
Yes, sir, it's visible, sir.
May I start?
Yes, sir. Yes, sir.
I wish you all a very good morning. At the outset, I extend my gratitude to head of the department for inviting me to have the interaction with the learned faculty members from across the country in this important FDP. And I hope that all the participants in this program, as well as the team managing this FDP, they are doing well in all regards. Dear participants, my talk is on an interesting topic, AI/ML in Internet of Things. See, nowadays, when we talk about to identify the emerging technologies, sometimes also called as cutting edge technologies or disruptive technologies, then these technologies include some prominent one. These are 5G, it's very important infrastructure for internet, cloud computing, AI/ML, blockchain, and Internet of Things. And there are some more, but these are the prominent technologies which have caused disruption in the technology domain. As far as the word Internet of Things is concerned, you will appreciate that it is primarily extension of internet. And the role of internet in our life has become something like, see, if we consider oxygen as the first requirement, then probably internet has become the lifeline after oxygen on this earth. And COVID has rather made it so important, a part and parcel of our all activities, that if internet is there, life is there. Internet goes, life goes. This is how internet has become so important. Internet of Things is extending this aspect to connect those things which are not still connected. Let us see how do we define Internet of Things. Then I shall, in this talk, I shall try to give the basic features of Internet of Things implementations, or I may call it as IoT networks. Then we shall see that what are the existing issues given IoT implementation, and how we can improve those things by integration of AI/ML into IoT implementations. Well, this is the primary definition. What is the vision of IoT? The vision is simple, that let us connect everything we see in and around us onto the internet. Primarily, it is a network of physical objects. And in this term, they have used the word things, and the things has a special meaning. Here I have written the salient features of things is that these objects are enabled with the capabilities of sensing, the capabilities of storage, the capabilities of data processing and communication. And for example, when a sensing ability, storage, data processing and communication interface is embedded into a thing, we call it as a smart thing. So primarily, when we call Internet of Things, the things word connotes to smart things. And these smart things again are able to hear, they can see, they can think, they can cooperate, and they can coordinate in the decision-making process. And the best example, which most of us are using nowadays, is a smart mobile phone. So, from definition point of view, Internet of Things is a network that connects uniquely identifiable things to the internet. Here, one thing is important. Is it okay now? Hello?
Yes, sir.
Hello?
Yes,
Sir,
sir.
yes, sir, it's clear, sir.
Okay. So, uh, so starting with the Internet of Things vision, it is a network of physical objects that connects uniquely identifiable things. This uniquely identifiable things means that when we connect anything, any computing device or any object onto the internet, it must have a unique IP address. And it means that the things we are going to connect to the internet, they must have a unique IP address capability. From importance point of view or significance point of view, IoT is a great enabler to do the integration of physical world with the virtual world. And this integration happens through communication technologies. So in the next slides, I shall share communication technologies and their problems and how we can overcome those problems with the help of AI and ML. But primarily, IoT is an enabler to integrate physical world with the virtual world through communication interfaces. Here is a brief snapshot that a person is holding a display, and this display is directly monitoring the activities going on in this built-up environment. So you can visualize what is happening in this built-up environment onto his screen. So this is a very good example of integration between physical world and virtual world. And you know that this integration is known as a cyber physical system, which has almost become a academic discipline in engineering and technology world. Concept, let us extend the concept of IoT. IoT connects us or connects the world onto the internet anytime, any place and anything. Here I have considered three axes. On x-axis, internet will enable us to place the communication any place. There is a word in technology, we call it ubiquitous. So it offers ubiquitous connectivity. The environment may be outdoor, could be indoor, it could be at the computer itself. Then on the y-axis, this communication will happen anytime. Whether you are on the move or at night or daytime, doesn't matter. You are on the internet. And then anything. The communication through internet can happen between computers. It can happen between human beings. They may not use a computer. They may use some fittable wearables. Human to things, they may use some generic equipment, and think to think, which primarily talks about machine to machine communication. So fundamentally, IoT concept is going to have anytime, any place, and through anything communication. Regarding why IoT has become such a disruptive technology nowadays, everybody is talking about IoT. Even if you pick up a newspaper, you'll find some article on Internet of Things. In fact, IoT is going to connect everything from industrial equipment to everyday objects. It is an enabler to connect inanimate things, like you may start from gas turbines, automobiles, utility meters, which we call as smart meters, plus living things, could be plants, farm animals, and people. So here the spectrum of connectivity is going to connect everything almost onto the internet. As far as application domains are concerned, internet is finding wide applications in critical infrastructure. Can be power grids, agriculture, military, home appliances, healthcare, education, so on and so forth. You name any domain, you'll find that IoT has some applications. Energy, built-up environment, medical, retail, intelligent transportation systems, which is an integral part of smart cities, manufacturing, industrial IoT, industrial Internet of Things, is the basis of Industry 4.0. Use cases is an interesting case, like I have written over there, farm animals. It is a project in Essex, cow tracking. They have used an IoT network to collect the data from radio positioning tags, which are placed onto cows to monitor their illness, to track their behavior in the herd. So you can appreciate that IoT is becoming an integral part, a part and parcel almost in all walks of life, whether it is personal, corporate, professional, governance. When we look at the IoT as an ecosystem, what does it consist of? You will agree, some of you may have some understanding, or maybe may have done some courses. It consists of physical objects which are embedded with sensors and actuators, controllers, plus internet. So this entire ecosystem of an IoT consists of these primary elements. When we say a technical framework of an IoT device, we start with, like I've written, object. And the best example I given is a smartphone. This smartphone is enabled with sensor, like it is having camera. So camera is a kind of sensor. And of course, it is having networking interface, because your camera, you can connect your smartphone to the internet through Wi-Fi, through Bluetooth, through cellular networks. So it is having multiple networking interfaces. Another example, Fitbits, wearable fitness and trackers. So these are the few typical examples of IoT devices. Then in this framework, the second component is communication technology. Because you have to remember that when you collect the data through sensors, you may process, you need to send it through internet onto the other end. And for that purpose, you need to have some communication protocol. So communication technology here primarily refers to a communication interface. And remember, communication interface can be wired as well as wireless. And then of course, internet. Internet in this framework is the carrier. It is an infrastructure which will carry the information from one point to another point. And the fourth element in the framework of IoT is processing and storage. This is another schematic of IoT. Let us start with these are the objects which I have referred in the previous slides, like we have Fitbits and wearables and smartphones, so on and so forth. And these objects are essentially embedded with sensors and transducers. And then having collected this data through these objects, then this data collected is sent to the communication network, and communication network needs to send this data to computation systems. This is another schematic. Here are the again smart things. I shown some industry lights and some energy kind of things, some sources, house, cars, and so on. All these things we assume that they are embedded with, they are fitted with some sensors and actuators, and those sensors and actuators have some amount of intelligence. And this intelligence primarily states that they have the decision-making capabilities. Then, of course, when this data is collected, you need to have a gateway, and then gateway to middle layer. You see here is the role of AI/ML. This is important. This is what I want to convey, that the role of AI/ML is at this place, middleware, where the data needs to be processed, it needs to be analyzed so that we can make the decisions, and then you can apply those decisions in certain applications. This is again data flow and control flow in the entire framework of IoT. So almost the things are same, but it's another way to show where the ML fits in and what is the requirement of ML. Again, you see that there are physical objects, sensors and actuators. And when we look at IoT as a network or data network or computer network, then we divide the functionalities into different layers. So this first layer is known as sensing layer. Sometimes we also call it as perception layer. Then we have network layer. This is the data collection part. Remember, sensing layer, the primary function of sensing layer is to collect the data. Then the second part in hierarchy is data transmission. And the data transmission is entrusted with network layer. Network layer is again fitted with internet gateways and network gateways. And here, data acquisition system along with some sort of networking technologies is required. Then this is process information, data processing layer, processing unit. So you have the data and you have the capability to transmit this data to some processing unit, data processing unit, where analysis and decision making process can happen. And this third process of information is the place where AI and ML is looked into. AI and ML is leveraged. And once you have the data, you have extracted the information from the data, then you can use this in the application layer. The application layer is something like you have driverless cars. So in driverless cars, you have to collect the contextual information from the surrounding. You analyze that data and then take the decision to steer the vehicle. So that steering of the vehicle in driverless cars happens at application layer. So it becomes an example of a smart application and management. So this shows primarily that where AI and ML is required in Internet of Things. This is I find is again important before we enter into AI and ML domain in IoT. These are the various technologies. See, I do not claim that only wireless technologies are used in IoT as a communication protocol. There could be wired technology as well. But as far as personal applications are concerned, wireless technologies provide flexibility of movement. Otherwise, OFC and even Ethernet. Ethernet could be used for IoT kind of things, but in that case, the end user equipment has to be stationary. So wireless technologies are more abundantly used. Here, there are various technologies which I have shown with respect to their range and the data rate and power consumption. So you start with RFID, is very popular. RFID, these are the tags which are used. You see that at toll taxes, tags are being used on the vehicles where the toll tax is deducted automatically. Then we have uh, Bluetooth, low energy, ZigBee, Z-Wave. These are another technologies which are being used in IoT networks. Wi-Fi, you see that RFID has very low data rate. But if you move up, you'll find that Wi-Fi is having 100 Mbps. And some of you may raise that the question that now the Wi-Fi, we call it as Wi-Fi 6. It is supporting the data rate up to 1 Gbps, the next new version of Wi-Fi. So it is not just 100 Mbps. So I just want to say that Wi-Fi is become very powerful in the time to come. And it is going to give the competition to uh, wired network, except privacy and security issues. Because wired networks are supposedly more secure and Wi-Fi works on the airwaves. So that has broadcasting nature. So security is a major concern in Wi-Fi, but otherwise the data rate provisioning in Wi-Fi is increasing like anything. And these are another technologies, cellular 5G. You see that uh, in the time to come, if you talk about Industry 4.0, which is again based on industrial IoT, shall be using 5G networks. Fortunately or unfortunately, in our country, 5G is yet to be launched. And today, I got the news that our government has decided to auction the airwaves in next year, 2022-23, for 5G implementation. So here, one point I want to make that industrial IoT shall use extensively these cellular 5G networks. So when the purpose of showing this slide is that when you have some applications, you have to pick up the right communication interface, the communication protocol out of these. There could be some more, but these are a few indicative list. Wi-Fi, just to have some descriptions. Energy requirements in Wi-Fi are large, and because you will agree with me that Internet of Things, they are most of the time battery operated. So they cannot use a high energy, they cannot meet high energy requirements. That is the limitation. As I written Wi-Fi 6, it is having a theoretical capacity of 9.6 Gbps data rate. ZigBee is very popular. In BTech programs, a number of students do the projects, hardware projects on Internet of Things, and they use ZigBee. It's an open global standard. And the designation of this standard is IEEE 802.15.4. The range is small, 100 meter, but it can be extended by relaying the sensor nodes. It is a low power technology. It is used in frequency exempt band, 2.4 gigahertz, 900 megahertz. A low duty cycle. So if duty cycle is low, then naturally the battery life will be prolonged. It is secure because it is using 128-bit AES encryption. However, power efficiency is not good. It is good for home automation as well as lighting system. This is another communication technology which is used in IoT, wireless personal area networks. Like we have been using Bluetooth for so long. Whenever you want to download the photographs from one equipment to another equipment, you use Bluetooth. Even mouse is connected to laptop or other devices through Bluetooth. It has wider applications. Printer is also connected, maybe connected through Bluetooth, so and so forth. So the point is that for IoT, there is a customized technology We call it as Bluetooth low energy. And it is being developed for small scale consumer applications, mostly used in conjunction with electronic devices like smartphones, and it is used to transfer the data to cloud as well. Integrated into fitness and wearables, smartwatches, glucose meter, pulse oximeter. These have been very common during the COVID time. But the point is that BLE is being explored, developed, and deployed in a generalized class of IoT implementations. Narrowband IoT, yes, this is very prominent technology because whenever we want to use cellular networks, the point is that Wi-Fi has a certain range, because if you have a building, you can have Wi-Fi, but if you want to have larger coverage across the country, across the world, then cellular networks is the only choice. And this narrowband IoT is primarily based on LTE. But here the issue is that LTE works in license band. So license bands, they have to procure the license from the government. So it is a little bit costly. However, this narrowband IoT provides a wider area, which is our requirement, particularly in on highways and rural areas. And simultaneously, it is low power. And it is being explored for a wide range of IoT devices and services. It has a good improved power efficiency. Cellular networks are secure as compared to Wi-Fi, and it conforms to third generation partnership project. Very good indoor coverage. It supports to massive number of connected devices. Low cost of connectivity. Architecture is also optimized. Implementation is easy. This is another communication interface for IoT. Near field communication. This technology transfers the data by bringing two devices closer to each other. The range 20 centimeter, you see, the range is very low, 20 centimeter only. And it works on the frequency of 13.56 megas. There is a tag reader in a mobile phone. This schematic shows how this reader works. Let us come to characteristics of these IoT networks. Having gone through the various framework components and particularly the communication protocols which run the IoT networks, let us see what are the special characteristics of IoT networks. The very first is super scale connectivity. In fact, internet is nothing but connecting everything onto the internet. So it is going to have massive deployment. This is the first characteristic. And the repercussion of this massive development is the architecture. Because we need to have an architecture which can support such use deployment of the devices. We are going to have everything onto the internet, and the new name of Internet of Things, which is given by Cisco, is Internet of Everything, which of course is going to connect people, places, objects, and things. So this is just one figure. It may vary with respect to time. It is expected that 75 billion devices shall be connected by 2025. The implication of this first characteristic of IoT network is that what kind of architecture we could design to support this massive connectivity. Then second feature of IoT network is heterogeneity. You see that IoT is not using only a few, like it is not just based upon mobile phone or laptops. It is having a multitude of different devices. You see that even air conditioners, freezes, TV, you name anything, watches, everything is going to become a part of this network. And all these networks will be using different communication protocols, like we have just seen in the previous slide, different communication technologies, different standards. So there is a huge heterogeneity in the IoT networks. This is another issue. Communication in close proximity. We have seen that internet, if you go to a factory floor, then area covered is not large. It is just collecting the data from one table, processing that data, fitting into the device, and then sending it to the next table. So communication is happening in close proximity. D2D, DSRC. D2D is device-to-device communication. This device, DSRC, basically is used for intelligent transportation systems. The fourth important characteristics is ultra reliable and a low latency communication. You will agree with me that when we talk about navigational layers, we talk about industry IoT, IIoT 4.0. Here the functions happen, the operations happen without human intervention or with minimal human intervention. So this networking aspect, the communication must be ultra reliable and it should be fast. Latency primarily refers to faster communication. You probably you remember that in cellular networks, particularly if you take example of LTE, the latency is on the order of 10 milliseconds, and practically it offers 50 milliseconds in a practical implementation. But in IoT networks, this has to be ultra reliable and low latency communication. You have to see how AI and ML can reduce these latency requirements and how it can make the link reliable. This is a very important scope for the use of AI ML to achieve ultra reliable communication links. In critical infrastructure, delay and reliability has become very important. Another characteristics is low power and low cost communication. We have been talking about to use the IoT in agriculture, and in agriculture we cannot have high power devices, or we cannot invest too much. So the communication has to be low cost and it has to be low power. Self organization, self healing, dynamic changes. It is, of course, you see that even our mobile phones, they go into sleep mode, their wake up time. So when they wake up, they become a part. Basically, when they are wake, they are made to wake up when they need to send the data, receive the data. So they make dynamic changes in the network. Safety, because IoT networks are ubiquitous, so safety has become, of course, an issue. And you see that the devices are smart. So there is an embedded intelligence in all these devices. So well-informed decisions are taken based on the process data. These are the important characteristics of IoT networks, and these pose certain challenges. If you look around these applications, which we have seen earlier, you find that the communication happens between machines. They talk to each other through internet, and they share the information, they coordinate in decision making, and there is no human intervention. So machine to machine communication is going to become the important component as far as IoT is concerned. Even industrial IoT is purely based on machine to machine communication. And the 45% of the traffic in IoT, they say, is contributed by M2M. And interestingly, there is a projection that connected machines over the last 5 years, they have grown by 300%. So this is a very special characteristics of IoT implementations, that communication will happen between machines. Let us see what are the issues. Having gone through so many things of IoT, you see what is the design philosophy. And sensors and actuators, they of course are designed based upon the requirement. Like you have a pH meter, you have glucose meter, you have, let us say, humidity, temperature, and all those. That is one part, and that basically that is available to a great extent. All these sensor actuators are available, and we can pick up those based upon the requirement. Now we come to the design philosophy of communication range. Here the communication happens through airwaves. And through airways, because the communication is broadcast in nature, and broadcasting environment is very hostile. It is not deterministic. It is highly uncertain. Whether you talk about cellular, whether you talk about Wi-Fi, Bluetooth range is less. So there may not be so many issues as far as link reliability is concerned. ZigBee also, but anyways, even if you have a smaller range, you need to design some link budget. All these design and development is done through mathematical modeling. For example, if you talk about cellular networks or even Wi-Fi network also, when you want to deploy an access point in your, let us say in your home or in your hostel or in your building, so you have to have a idea of communication range. And that communication range is decided based upon empirical formulations or analytical, like in cellular networks, this is a simple formula that this is the received signal strength. These are some constant distance. Of course, these are based upon frequency and antenna parameters, and this is the fading parameter. And we can analyze, we can always calculate what is the transmit power required for a given transmission range given the environment. This is how the design is done in case of communication technologies. Now, the issue is that uh, having seen the previous technologies, the radio interface, the IoT implementations, they are required to operate in highly dynamic environment. See, uh, typically on factory floor, it may not be dynamic, but if you go to forest, it is highly dynamic. If you go to agriculture, it is highly dynamic. If you, let us say, you go to even navigational aids or say driverless cars, they are required to operate in highly dynamic environment. It's a keep on changing. Then channel impairments in radio interface, they cause a lot of problems. RF interfaces, hostile environment, fading, mobility, Doppler spread, this and that. Indoor applications, essentially non-line of sight communication. They cause a lot of scattering. So the point is that in IoT, given having seen all these aspects, it's a very complex environment. Radio propagation environment is complex. If you look at the framework, you'll find that when we collect the data, we send it to the network layer, and this network layer sends this data to the processing unit. In this process, this data transmission has to suffer a lot through this extremely complex radio propagation environment. And it has been found that mathematical models, which is the conventional technique to design these implementations or networks, those are not adequate to characterize the system performance. They cannot be represented by mathematical modeling. The idea is simple that now the operating environment of these communication technologies, is very complex, very uncertain, and very hostile. And those who are a little bit into machine learning, AI, ML, you'll appreciate that AI and ML takes the care of these uncertainties. It is the technology, powerful technologies, which can work, which can respond to these uncertainties and can offer consistent performance. Again, IoT implementation, you take again the stack nature, functional nature. I have shown in the framework that sensing layer, perception layer, physical layer. At physical layer, interference is the major issue. And we take the decision based upon recognizing this interference. See, those who are in wireless networks, they may agree with me that when we talk about LTE and when we talk about interoperability, when we assign the resource blocks, the assignment of resource blocks is a function of the interference. So if at a particular link interference is more, then we do not allot the resource blocks to these highly interfered links. We find that the link which are having lesser interference, they should be given the priority of RB so that we can maximize the performance. So we need to recognize this interference. How to recognize this interference? And interference is not deterministic. It is uncertain. This is where this causes a lot of complexity in recognition. MAC layer is a link quality. How to predict the link quality? This is again a function of MAC layer. Network traffic, all the routing. Routing is based upon so many factors on the link. How to estimate the traffic? If a traffic on a link is more, then you will not like to route the packets onto that link. You will rather have another route. But for that purpose, you have to do the estimation almost in real time. So this is just an indicative list that how the complexity is coming into the IoT implementations. Recognition, prediction, estimation, how autonomously extract these traffic patterns, and how to predict the trends. We can use these patterns to optimize the parameters for enhanced network performance. The intelligent solution AI/ML is the best tool for this purpose. So till now, I have tried to see what is the basic framework of IoT, what are the specific characteristics and what are the issues, what are the challenges to have the consistent performance, and primarily focused on the radio interface part, airwaves. And we have seen that yes, there are some challenges which cannot be overcome, which cannot be addressed by conventional methods. Rather, AI and ML is leveraged to address these issues. Now, any questions before I proceed to the next part?
So there is one question in the chat box.
Yes.
What kind data storage are used for weather forecasting?
See, for weather forecasting, they are using cloud. I tell you that nowadays cloud is also having some problems. But for weather forecasting, you need algorithms where huge processing power is required. At edge devices, we may not have the sufficient storage, so they are using the cloud services. However, cloud services are having some problems like latency. Cloud is not available at the application site or implementation site. Cloud is far away, like Amazon or this Google, they have their own cloud services. So cloud services means they have some computing and storage power. So they have installed server somewhere else. So you need to transmit the data over there. The algorithms are operated on that data. The decision is taken and then decision is again transported. So it takes a lot of time. So that causes huge latency or propagation delay. So they say that now if you want to have real-time experience like in case of driverless cars. So driverless cars has to operate in real time. So very low latency, it has to work immediately. If you see some obstacle comes, then you just decide obstacle has there, you have to steer the car in another direction to avoid that obstacle. And in this case, if the cloud is far away, it cannot work. So what they are talking about, edge computing. And in edge computing, there is another layer beyond this perception processing layer where you have more computing power. So, but as far as weather prediction, they are using cloud services. Use resources are required. Yes, let us come to artificial intelligence and then we shall integrate. I'm just refreshing your memory what artificial intelligence is, what machine learning is all about. Simply, in simple words, artificial intelligence is imitation of human intelligence. And in this functional domain, the machine is taught to learn through huge amount of data, as we human being do through our experience. We use our experience like when a child grows, he may not having the knowledge about the surroundings. Sometimes he may touch, he is not supposed to touch. But once he touches, he gains the knowledge that this is dangerous, this is fatal, this is hot, this is cold. So he basically collects the knowledge, having the interaction with the environment. Here, the machine is taught to learn through the huge amount of data. So our learning happens through interaction with the environment, with the interaction with the people, interaction with the objects in our surrounding. the machine in the same way learns through huge amount of data. And what is the purpose? See, the initial purpose was very good to reduce human efforts in repetitive decision making. But now there are several ethical issues, moral issues as well. So there are some people who says why we should use artificial intelligence, machine learning, all those. Anyways, the starting point was that there are some repetitive things, drudgery kind of things, where the intelligent machines could be used instead of human being. As far as ML is concerned, it is an enabling tool for AI. And it is an enabler to solve complex problems without explicit programming. See, there is a definition. Sometimes we ask our students that you define what is these machine learning and AI ML. So here is this definition is according to IEEE. It's a computer program, and it is said to learn from experience E with respect to some class of tasks T and performance measure P. If its performance at tasks in T as measured by P improves with experience C. This is ML. So the first inference we draw from this definition is that AML is basically a computer program, but it is not explicitly programmed. I mean, it is the programming. There is an instruction set, and the computer fetches these instruction sets in a certain order and then keep on taking the decisions. But here, the experience is done through action. So this program basically is said to learn, is made to learn from experience with respect to some class of tasks. There is one more term which is very difficult to realize, learning and generalization. See, we as a human being, we are supposed to have natural intelligence, human intelligence. Uh, See, if we take some kind of experience in one environment, sometimes we try to use that experience in another context. That is known as generalization. Here I have written that if the laugh in past tense would be used as laughed, generalization is that jump should be used as jumped. So this basically aspect says that learning in one environment, can it be used in another environment? We as human being infer this kind of experience, but for the machine, it is a difficult process. It is still a limitation and it is a problem, but transfer learning is coming another area of knowledge in case of machine learning, where this aspect is considered in transfer learning, that experience in one domain could be used in the another domain. So this you have to remember, learning versus generalization. Foundation of ML. Having the definition that we make the machine to learn without explicit programming. That is the fundamental definition of machine learning. How does it work? Primarily, it does extract the features from the data. And it turns this raw data into information. Why ML in simple? Why ML in IoT? IoT is what? It consists of a huge, large number of sensors. And all those sensors are collecting the data. So the first aspect of IoT is huge data generated by an array of sensors. And this ML, the purpose of ML is to turn this raw data into information, and then so that it can be made suitable for ML algorithms. Through these extraction of features, there is an elimination of redundancy, and then we facilitate the generalization during learning process. Generalization I have just defined. The goal is to find minimum number of features that will capture essential patterns. Primarily, it is related to redundancy. So it will capture essential patterns in the data. The methods are numerous. These are just few. regression, feature selection, regularization. For example, heart sound. In heart sound, the summary statistics is collected: mean, median, standard deviation. In frequency domain, you collect the data on dominant frequency, spectrum entropy, male frequency, coefficients, MFCC, and then you collect this data, you collect a table, you prepare a table, and according to that table, you decide some threshold, and you can decide what is the heart condition. So depending upon heart sound, we can devise a predictive model. So we have the data, let us say, of 100 patients with observations of last, let us say, 1 year. Given this data, we can prepare a predictive model, and that predictive model could be used to decide the heart conditions of new patients. This is how ML works. So this is just as I shared with you, that IoT means data generation. So this is the era of data. People say that this is data has become the oil, and it has the ability to learn from the data. So the point is that just extract the information from the input data and leverage it to improve the network performance. It has to be adaptive to the dynamic environment. We have seen that environment is very complex, and AI ML is capable to adapt to respond to those variations. Self-organization. Some of you might be knowing cognitive radios, where the transmitter is able to change its frequency. The transmitter is able to change its transmit power. So self-organization, you see what frequency could be the best. You keep on changing the frequency. You keep on changing the transmit power. Self-organization capabilities it brings in. Additionally, so we perceive that a computing system with ML, enabled with ML, it begins to think like a human being. And a normal human being is supposed to improve with respect to time, gain more experience, become more wiser. In the same way, we expect that machine will become wiser and wiser, having collected more and more data, working with more and more in the environment. Its ability to quickly solve a new problem. This is important, that we have a predictive model based upon the data. You can use that model to solve new problems. For example, in cellular networks, if you want to offload the traffic from one network to another network between neighboring base stations, this is a general problem in base stations because of the high power consumption. That if in a particular cell traffic is very low, so we can switch off that base station and transfer the traffic from that cell to another cell. So this is, and this happens in real time. So such problems can be solved through ML. Just to walk through the ML paradigms, there are 3 terms where we use different paradigms: supervised learning, unsupervised learning, reinforcement learning. Algorithms. There are many algorithms in addition to this list, but these are very conventional kind of algorithms: linear regression, nonlinear regression, logistic, decision trees, random forest, k-means, k neighbor, SVM, support vector machines, neural networks, recurrent. Neural networks are again divided into 2: conventional neural networks, recurrent neural networks, and in addition to that, there are so many others as well. Just to have a small, again, refreshing your memory, I'm just walking through these supervised and unsupervised and reinforcement learning. In supervised learning, there is a known set of input data. And for that given input data, there is a known response. So that we call as output. So input is known, output is also known. We call it as labeled data set. And then using this labeled data set, we train a model to generate reasonable predictions for the response to new data. So to learn a general rule, mapping inputs to outputs. Example is again the same thing which I have discussed previously, that heart condition. There is a known data set on certain number of patients over a certain period. We can collect those parameters with respect to age, weight, height, blood pressure, so on, and then decide on heart conditions. Then using that, you can have some sort of regression analysis and develop a predictive model, train a model to predict if a new person will have heart attack or not. So supervised learning basically works on given data, and regression analysis is a very good technique for supervised learning. It is suitable for problems that aim to predict a real valued output variable. Given a training set, the goal is to estimate a function f whose graph fits into the data. Once the function is decided, and whenever an unknown point arises, it is able to predict the output values that we have seen. It is something regression analysis. There are some scattered values, and you plot a curve, and using that prediction model, you can basically estimate what shall be the output for the given input. Mathematical formula. This is y is equal to fx is equal to q0 plus q1 x1 plus so on qn fn. These are the function parameters. So it is just a relationship between dependent and independent variables, and keep on predicting the continuous responses. One typical example is fluctuations in power demand, electricity load forecasting. This problem is becoming very important in smart power grids. Another approach of supervised learning is classification. The first one I showed, regression analysis. Regression analysis more or less works on empirical formulation, and that is curve fitting. Classification, basically here the data is segregated into different categories. So accurately assign the data into specific categories, and this works to predict discrete responses. So regression works in continuous process, and classification works in discrete responses. Again, the example of supervised learning through classification algorithm is whether an email is genuine or spam, whether a tumor is cancerous or benign. So this kind of prediction models are referred to as classifiers, and they come under the paradigm of supervised learning. Medical imaging, speech recognition, credit scoring, all these are good examples of supervised learning. Unsupervised learning. To form groups of the unstructured data according to its similarities and distinct patterns. Here we try to find some structures from the input data set. Here in the supervised learning, see, for the given input, we had known the output, the response, and then a model was prepared. Here, we don't have such response, but the algorithm needs to find structures in the input data, hidden patterns or intrinsic structures in the data. It aims to learn a function to describe a hidden structure from the unlabeled data. And remember, in IoT networks, where complexity is more, the data in real-time problems is maximally unlabeled data. So this you have to carefully know that in IoT kind, where the atmosphere is uncertain, the most of the time the data collected is unstructured. However, unsupervised learning algorithms, they are able to draw inferences from these data sets and input data without labeled responses. This is another level of understanding. Clustering is a good example of clustering algorithms. Unsupervised learning is a paradigm. And in this paradigm, clustering algorithms is the approach. It's the most common unsupervised learning technique. And similar pieces in cluster, say like some of you might be worried save the resources, we put the sensors into a cluster. We select a cluster head, and then through selector head, we collect the energy from, collect the data from the nodes in the cluster, and that cluster head is responsible to transmit the data to the next cluster head and the base station. So here, based upon some criteria, clusters are formed. Similar pieces of information are grouped together, and then we try to have draw the insights from medical imaging to distinguish between different kind of tissues. This is a good example of clustering of unsupervised learning. Gene sequence analysis, market research, object recognition, they are good examples of unsupervised learning. So medical IoT in medical healthcare, these clustering algorithms are used. K means clustering algorithm. Centered, it is based on centered or distance based algorithm. We partition the n data points into K clusters, and each data point primarily belongs to clusters with the nearest mean. So it computes centers, iterates until it is optimal center, so on and so forth. So this is another clustering algorithm which is used in unsupervised learning. Principal component analysis, this is another technique in unsupervised learning. It's a dimension reduction tool. Transforms the larger data set into a smaller data set. So by identifying the correlations and patterns, preserves most of the valuable information. Orthogonal linear transformation, it transforms the data to a new coordinate system. Covariance matrix is used. But remember, these approaches are mathematical in nature. Highly complex mathematical in nature, so it takes a little bit time when we start to do this. But the point is that we try to have the correlation among these data sets between variables, and because it is a dimension reduction tool, so feature redundancy is reduced and we enhance the efficiency. And application, you just mark this: detection and identification of anomalies in wireless networks. So in IoT, there is a problem that there could be some anomaly detection, like you put an IoT network for in a forest area, or you put an IoT implementation in a border area. If there is any sort of anomaly, then it should generate an alert. So detection and identification of anomalies in wireless networks may be done through principal component analysis. K nearest neighbor, this is another approach, but this is supervised learning, and it is used for associating new data points to the existing similar points. So K nearest point has some advantages, that it has no training phase. It memorizes the training data set, and it is easier, simple. It's a 2-parameter value of the K and the distance function, which is the criteria. And initial assessment is based on simple classifications. It's a very fast algorithm, as it does not require any training period. And it stores the training data set and learns from it at the time of making real-time predictions. However, there is a problem. So whenever you pick which machine algorithm I should use for a particular IoT implementation, you have to make a comparison that this KNN is very fast, but its performance degrades in a larger data set. So if a network is small, it is good. But if there is a high dimensional data, if there is a bigger network, then it does not work well. Yes, deep learning. This is another term, and which is now more in use. Essentially, it is a feed-forward neural network in which each neuron is connected to another. And it is a very general question: what is the difference between deep learning and machine learning? It has multiple hidden layers. It has the ability to work with unstructured data. So it is becoming important for IoT implementations, because in the real world, maximum problems generate unstructured data. Deep learning has the ability to work with that. Images, text, there are various formats of data collection. So different formats can be used to train DL algorithms. It scans the data, identify the features, correlate, and then combine to promote faster learning. There is another feature of deep learning, which is not available in machine learning. There is a massive parallel computation. It's a distributed computing. So model learns to perform classification tasks directly from images, text, or sound. These are various formats. State-of-the-art accuracy it is observed that deep learning algorithms, they offer more accuracy. For example, driverless cars. Remember, driverless cars is an example of Internet of Things. It is driverless cars are just embedded with so many sensors. So it makes an IoT implementation. So this DL is the key technology for driverless cars. Enabler for recognizing a stop sign, distinguish a pedestrian from a lamppost. Key to voice control in consumer devices like phones, tablets, TVs, and everything. So DL is being used widely. There are some issues with deep learning. Technical challenges. Overfitting. Adversely affects their generalization capabilities. Their models tend to be overconfident about their predictions. And this becomes problematic in self-driving cars, medical diagnosis, trading and finance. There is a Bayesian method. So we shall discuss about Bayesian method some other point of time. But just remember that overfitting is a problem, that is overconfidence. Artificial neural networks. You see, the deep learning is a feed-forward neural network. So just to have an idea, this is slide just to make you walk through. It represents basically an arbitrary function, y is and nx. So these artificial networks are primarily feed-forward networks. Recurrent networks are built using a successful of one input layer and succession of one input layer, a number of hidden layers, and one output layer. So primarily ANN make a DL. Input variables X, output variables and prediction Y. Simplest architecture. Let me connect the. Just a minute. Yes. So I just want to show that ANN has certain architecture. CNN and RNN, these are another versions of this. Reinforcement learning, yes. This I just want to give a 1 minute on reinforcement learning. In paradigm, I have shown supervised learning, unsupervised learning, and reinforcement learning. See, there are various applications where data is not available. No specific outcomes are defined. So the agent, the operator, it has to learn from feedback after interacting with the environment. And this is widely used, like I tell you, in D2D communication, reinforcement learning is widely explored. We don't have the earlier data. We don't have the historical data. So it performs some actions, makes the decision on the basis of reward, and then agent aims to optimize a long-term objective by interacting with the environment. It is based on error and trial process, reward and penalty. And if there is a correct move, you give the award. If there is a wrong move, it's a penalty. Facebook is using an open source learning reinforcement platform. Another is the oil industry. Sometimes you don't have the historical data, like there is an exploration of oil from some place. At this place, you may have the data with respect to some other place, but you may not have the data corresponding to that. So they say that in such places, reinforcement learning could be a good approach, could be a good paradigm of machine learning to do these applications. Dynamic application robots, this is another area. Transfer learning, I told you about generalization. That we as a human being, we take the advantage of previous learning in different environments. So suppose you go to a very area where the temperature is very low. So whenever you go to another area where it is expected that the temperature will be low, then you take all necessary measures which you were required to take in the previous place. So this is known as transfer learning. The experience, let us say, I'm teaching in a certain institutions. I gain some knowledge in a particular area. When you shift your area a little bit, then you have some built up knowledge in the allied area, which you can build up in the next area or in the switched area. So that is known as transfer learning. This kind of learning in machines is a challenge. And though it is being realized through neural networks training, but it is very consuming. It takes a lot of time. Utilizing the knowledge from a specific domain to assist learning in a target domain. So store knowledge gained while solving one problem and apply it to a different but related problem. So the advantage is that we want to avoid the learning from scratch, resulting in an accelerated learning process. This is a new paradigm in machine learning, that is transfer learning. In deep learning and reinforcement learning, knowledge can be represented by weights and Q values. Say DL for image recognition, we may use the weights that have been well trained for another image recognition task. This makes transfer learning. Satisfactory performance with a small training set. So in conventional machine learning algorithm, you have the data and then you train your model on that training data set. You apply this in another domain, then you again have the data, you again train. So training leads, there are two parts in machine learning, training and validation. So most of the time is consumed over training. Here they are economizing on the training data set, having the advantage of previous knowledge. Reinforcement learning, it's based on Q values. So basically you built up on the previous environment. However, there may be a negative impact of former knowledge on the performance. Like you have some knowledge in one domain, you want to apply that knowledge another domain, and another domain may not fit into that kind of environment you have done. So it can be a negative impact of former knowledge. So this is a research area and transfer learning. Well, having all these ideas about IoT, their challenges, different machine learning, deep learning algorithms, reinforcement learning, let us have some specific problems in communication. See, in communication, I'm talking about the communication protocols, communication technologies which are being used in IoT. But in general, the link performance is measured in terms of SNR and bit error rate. The throughput is measured in terms of how many collisions are taking place, how many retransmissions are done, what is the packet loss rate, what is the latency, how much is the energy consumption. These are the major performance indicators in all communication technologies. Physical layer, as I told you that if it's wireless communication, if we are using wireless technologies, then of course radio propagation is a major challenge. MAC layer collision we need to avoid because it happens carrier sense multiple access. So it is a contention based access. How to avoid the collision so that we can increase the throughput. This is again an area where ML could play an important role. Back of exponents, contention, window size. These are the parts of implementation of CSMA. Network layer is responsible for traffic and routing. So these are the various domains where leveraging of ML could enhance the performance. Scheduling, machine learning is being explored for scheduling. It's a fundamental functionality in wireless networking. What we do that we distribute the available capacity, say channels among the existing connections. So the process in which evolved node base station, which is a terminology in LT, decides which user equipment should be allocated the resource, send and receive. This is done through scheduling. Even D2D networks is a typical example. Proximity links, they produce significant interference for each other whenever they are simultaneously activated. So to which link we should provide the resource, that is done through scheduling. So goal of scheduling is judiciously activate a subset of mutually compatible links so as to avoid excessive interference. Tell you, this is a very good research problem in D2D resource allocation. So IoT, which is based on IoT, I told you that IoT is the one specific feature of IoT implementation is proximity communication, and D2D technology is an enabler for proximity communication. But in D2D, when you want to make direct communication between two devices, you need to have the resource from LTE, RBs. So allocation of RBs is based upon the interference level. This is what I have written, that scheduling, which is ML enabled, will judicially activate a subset of mutually compatible links. So you will pick up those links which are causing least interference to each other. So if interference is least, then you can maximize the network utility. You can improve the performance. And this is where interference calculation. In previous slides, I've again given you the idea that if we have the estimation of interference applied, then we can choose the judicious, we can have better links, judicious selection of the links. This is what, but this problem, though I'm not stating scheduling has been used widely in internet, but now scheduling is being done through spatial DL, deep learning. D2D networks, which is interference pattern is largely determined by relative locations of transmitter receiver. So they learn optimal scheduling based upon geographical locations of neighboring transmitter receiver pairs. This geographical spatial convolution of locations of interfering or interfere neighboring transmitter receiver pairs. So they can eliminate expensive channel estimation process. This is a very typical and good example of deep learning algorithms in scheduling in IoT networks. I'm again repeating, the purpose of deep learning is to collect the information about locations of the interfering or neighboring transmitter receiver pairs. In D2D networks, is an example of proximity communication. The base station is bypassed. Communication happens between two devices which are in close proximity directly, but they need the resource blocks. The resource blocks allocation is done in view of the minimal interference between the neighboring pairs, neighboring links. This is what I have written here. This spatial convolution of locations is derived through deep learning algorithms. This is very interesting problem. Radio identification. There's a few more problems which can be addressed or which are being addressed or at least attempted through machine learning. AMR, automatic modulation recognition. Some of you who are in digital communication, they will appreciate it's a very interesting problem now coming up. See, particularly in a defense area, enemy will always try to fool the target. And if you want, and for any establishment, it is important that if they cover any communication, they would like where from this communication is coming, what this communication is all about, what is this communication. This communication may be from a friend, this communication may be from foe or enemy. And because communication is not in baseband, communication is modulated. So if you want to learn about what kind of communication is happening, you need to have the idea about what kind of modulation is happening, so that if you know the modulation, at least you can detect. But if you don't know what kind of modulation it is, then it is a blind signal. So if you are having a blind signal, then out of that blind signal, how to derive the information? You need to have the detection, you need to have the demodulation. And this technology, we require AMR, automatic modulation recognitions. If you receive at your end a blind signal, a blind radio signal, you should be able to derive, to infer what kind of modulation this signal is using, so that you can judge, you can decide what is the signal and what is the information. So modulation, automatic modulation recognition. Interference identification, we have talked a lot. Technology recognition, which technology is this? Signal identification, emitter identification. These are very important issues. They come under the heading of radio identification. And ML is responsible. ML is a very powerful tool to achieve these objectives. I'm again repeating, automatic modulation recognition, very important area in defense applications. AMR or AMC, sometimes we also call it as EMC. Interference identification, again, is very important in radio identification. We come to know what kind of technology this signal is using, like it says Bluetooth, it is an it's a RFID, or it is Wi-Fi signal, it is a cellular signal. So basically, any defense establishment would like to know about these features. So ML is playing an important role in radio identification. I just want to give this is very interesting topic, I feel. AMR or AMC. It is playing key role in defense and civilian applications. So friendly signals transmit and received, but hostile signals, they must be located where from they are coming. You need to identify them. And you need to jam them. You can do the jamming only when you have the identification of those signals. It recognizes the type of modulation scheme an emitter is using to modulate its transmitted signal. So it's based on raw samples. This information can provide insights about the type of communication systems and the emitters present in the radio environment. Traditional algorithms, likelihood-based, feature-based, these are the primary approaches which are being used for AMR. They have good performance, but computational complexity is very high. Even Facebook approach, they use all these AMR. And well, now the new trend is that let us use machine learning in AMR. And here recognition is based on, I'm again repeating, the idea is that I want to know which type of modulation is used in a given signal, so that you can take the necessary action. You can jam the signal. So the objective is to detect the modulation. ML has better generalization abilities, but accuracy is still a problem and depends upon the experience. It's complex. Communication systems are very complex. We are having heterogeneous signals, heavy burden on recognition and detection of signals in complex radio environment. Ability of self-learning necessity. Here, convolutional neural networks, they are applied onto modulation formats. The CNN, so it's a technique of this is a technique of deep learning. They use in phase and quadrature phase representations of raw received signal. They are able to do optimal mapping from input raw signal to modulation schemes. They use dropout and Gaussian noise filters, and this is being implemented. So you can look for ML enabled. Resource allocation is another point. Quality of service requirements and real-time processing. The data related to historical scenarios is collected and feature vector is drawn. So we again, I talked about a little bit in case of a D2D where resource allocation is done. But to determine the resource allocation for a new resource, a new scenario, we need to identify the class of its corresponding feature vector. So the resource allocation problem is transformed into a multi-class classification problem. And that classification problem can be handled by supervised learning. Using even KNN is used to optimize the beam allocation in a single cell with multiple users. So this is our resource allocation. Radio resource management is again a very important problem in all networks, IoT networks or another networks, data networks. Supervised learning is primarily a classifier. And this labeled data set is composed of representing different scenarios and corresponding classes. So they belong to same class, correspond to the same resource allocation. Here, resource allocation can be done using classifiers. So important is that we draw the feature vector from the communication scenario, and then we can design low complexity multi-class amplifier. So just remember that radio resource management problem would be solved by classifiers. Routing. Routing is again in IoT implementations because a major limitation of IoT is resources. IoT is essentially an implementation with resource constraints environment. A resource constant in terms of energy, in terms of bandwidth, in terms of data rate, in terms of storage. So they are battery operated. They have sensors are not coming up with huge processing power. They are not coming with GPU. So what we do that routing enabled ML enabled routing is being widely explored for ultra dense networks. And deriving the proper paths for data transmission, delay, other types of performance, this can be optimized by ML. Reinforcement may even RL based routing is being explored. This is another area where access points are written base station. See, in agriculture area or health monitoring, access point or base stations is the point where you connect to the outside world or gateways through these base points. In order to save the energy, the traffic from off base stations could be offloaded to on base stations. So I touched this topic in previous slides as well. So we can do the clustering and clustering ML classifiers. So K-means clustering based on similarity of location and traffic load could be taken into advantages. So in each cluster, the interference is mitigated by allocating orthogonal resources among communication links. These are the various techniques which could be used to do the offloading. Network traffic prediction, again, it is important aspect in IoT networks. If we have a prior accurate prediction of user traffic, then we can improve the system performance. Like functional base station, sleeping mechanism may be adapted by utilizing knowledge about future traffic demands. This helps reduce the overall power consumption. Demand-aware network resource allocation, forecasting with high accuracy the volume of data traffic. It is being done through neural networks, but it improves a lot as far as network performance is concerned. This is another area, security. Security is a very very major concern, very typical concern, because IoT implementations a number of times are unattended. And when things are unattended, like you deploy an IoT network in a forest area. So there is no human being to monitor that. It is unattended. So this security is a major concern. Face recognition for forensic, this is another area. Character recognition, code injection and code identification, distributed denial of service attacks. All these are severe problems which can be handled by machine learning. Let me give some use cases. I find this areas very interesting and where IoT is having huge applications. IoT based precision agriculture. You will agree with me that in the time to come, the people are running from rural area towards urban areas. So urbanization is happening at a very fast pace, very fast rate. But you see that population is increasing like anything. We are going to have around 8 billion, more than 8 billion probably. The food comes from rural areas only. Agriculture land is decreasing. In order to ensure the food security, it is important that we enhance the yield. We do smart farming. This is where IoT comes into picture. Precision agriculture aims at ensuring food security. And I tell you, IoT has a very important application in precision agriculture. It's a technology-enabled, data-driven, sustainable farm management system. So IoT-based smart sensors, they are deployed in agriculture farms. And these sensors collect the data on soil nutrients, fertilizers, water requirements, analysis of the crop growth, disease in the plants using computer vision technology, satellite images. All these are the parts of this farmland management system. Through these sensors, we collect the data and we analyze the properties. Having analyzed the properties, we decide what kind of crops we should go for this particular soil. We prepare the land, we select the seed, we analyze the crop yield, we also select the fertilizers if we have a prior knowledge of soil properties. And these properties include surface humidity, soil moisture, pH value of the soil, what are the weather conditions in that environment, what is the life cycles of crops and nutrients as we have seen. So these properties we collect through these sensors having IoT implementations. Now, you collect huge data about the soil properties and then you use regression model. These are these are few works available in literature. I just referred one. They have collected the data which I have identified, parameters identified in the previous slides. And through this regression model, they were able, let us say, crop growth, crop yield predictions. They have used support vector machines and neural networks that these are the properties of this particular soil in this farm. And if you use this fertilizer, use this cycle of crop, this will be the yield of this crop. This you can have the knowledge about. Smart irrigation, real-time prediction. See, if you have the prior information about soil moisture, then you can decide, you can take the decision on smart irrigation, real-time prediction decision making based on data collected by the sensors and IoT-enabled systems. But here I tell you, see, these things you can do without machine learning, conventional method. The point is that if you use machine learning to have these regression models, the accuracy is much more as compared to the conventional methods. And secondly, because regression you can do in MATLAB. If you have data, I can have empirical formula. But here, if you use machine learning, then machine learning will keep on building up the knowledge with respect to evolution of the time. This is not fixed. This will take answer if there is a variation in the atmospheric conditions in the farmland, then machine learning will consider those points and then will make the changes in the crop yield predictions. So we keep our knowledge updated if we use machine learning. The point is that machine learning has the ability to learn from the environment and evolves with respect to time. So it plays a major role. Machine learning with IoT implementations is going to play a very important role in precision agriculture. It is enabling the farmers community with technology. The aim is to get optimum outputs with precise inputs. So smart sensors, actuators, images, robots, drones, all these are the enabling technologies. And regression analysis through ML approaches. can play a very important role. It can empower the farmer community to take the necessary actions in time and to improve the crop yield. I'm just concluding. It is projected that by 2025, 4 year in line, IoT is going to connect everything. We are fast moving to perceive a smart world where anything we can think of is online. Though nowadays also, say March 2020, prior to March 2020, we hardly give online expert lectures. We used to go to the place and then sit with the people and then talk in offline mode. But now everything is online, and Internet of Things is the technologies, the infrastructure which is going to connect everything onto the internet, making everything online. It is going to have huge impact, very huge impact on socio-economic life of the people. And it is going to become a major force in industry. I tell you that Industry 4.0 is entirely based on intelligent machines. AI ML based IoT implementation is envisaged to enable self-driven analytics and making smart decisions with minimal human interpretation. We are moving towards a new paradigm. We can call it as artificial intelligence of things. So it is not mere IoT, it is becoming AIoT. This is how ML is being integrated into IoT framework. Let us contribute as an academic towards the development and deployment of artificial intelligence of things. Thank you very much for patience hearing.
Thank you so much, sir. So there are a few questions in the chat box. Sir, I'm reading it for you. The question is whether it is possible to train a model in cloud and transfer the learning to edge devices, low computing power. If possible, what method of tools are used currently?
See, the GPU, minimal requirement is GPU to do the machine learning. And at edge devices, though, there is a trend now that we shall have edge computing. But conventionally, the machine learning algorithms are residing at clouds. So we transmit the data to the cloud, we do the data analytics, take the decision, and then this decision is sent to the application layer. This I shown in the framework. However, as I told you that there is a problem of delay for real-time experience. Real-time experience is causing a problem if cloud is sitting far away. So we are bringing this edge computing to the edge of the devices. I mean, there is one more layer. You can say we are introducing one more layer which is near to the sensors, which is near to the smart objects. So conventionally, the machine learning algorithms are residing with clouds or edge computing. Our smartphones and all those, they cannot support these applications. Use data, gigabytes data, they cannot handle as far as training is concerned.
Sir, thank you.
Thank you, sir. Thank you so much.
Sir, our head of the department, Dr. Ranjit Kaur, is with us. So I request ma'am to give the vote of thanks to our resource person, Dr. Brahmjit Singh ji from NIT Kurukshetra.
Very good afternoon to all of you. Am I audible?
Yes, ma'am, you are audible.
Okay, so very good afternoon to all the participants, and especially to our expert of the day, Dr. Brahmjit Singh ji from NIT Kurukshetra. I want to say thank you, sir, for sparing your valuable time for this expert talk. So I have only for 10 to 15 minutes and you have very well explained how we can use this IoT in the precision agriculture and how we can integrate this machine learning and artificial intelligence into the Internet of Things to make our world more smart, because in the coming time I think so everything we are going to see in terms of smart cities, smart buildings, smart office. So I hope your this expertization on this topic, artificial intelligence and machine learning integration into IoT, will be helpful to all the participants to understand the basics of this. Thank you once again for sparing your time.
Thank you so much.
Thank you, sir.
So,
Yes, sir. You can stop sharing your
okay.
screen.
Thank you, ma'am. Thanks a lot. God bless you all.
Thank you, sir. Sir, one more minute. I request the participants, they can switch on their camera so that we can have the group photograph with sir and with our head of the department. Sir, wait for a minute, please. Yes, give me one more minute. Thank you, sir, for sparing your valuable time and sharing your knowledge with us. Hope our participants will get benefit from your talk. And you have already shared with us your email ID, and they can contact you with their queries.
Yes. Welcome.
So,
Always welcome. I shall be happy.
thank you, sir. Sir,
Thank you.
you can leave, sir, if
Thank
you want.
Thank you, one and all. Bye.
Thank you, sir. Thank you so much. So, dear participants, we will reassemble at 2:30. You can have your lunch and we will meet at 2:30. I have shared the attendance link with you in the chat box. You can fill the attendance there. I have already shared the attendance link. I'm resharing with you. I'm resharing the attendance link. Kindly fill it.
Kindly confirm, is it audible and visible to all of you?
Yes, sir, it's
Yes, sir. Visible.
audible and visible.
Okay. So, ma'am, should we start?
Yes, yes, before starting, sir. Kindly conclude at 4, and 4 we are having the
Yes,
valedictory.
ma'am, sure. Okay.
4 to 4:30 we are having the valedictory session, sir.
Yes, ma'am. So, dear participants, we are starting this session. In between the session, we will interact in chat window. So we will discuss some points about the contents as per the schedule, and I request the participants to communicate in chat in between if we want to discuss something, if you have any query, or majorly the queries will be handled, will be taken at end of the session. So now we are starting this session. Kindly confirm whether audio and screen is clear to all of you.
It's clear and you are clearly audible.
Okay. So in this session, we will discuss about simulation of IoT scenarios using open source platforms. We will see by which way we can work on different implementations related to Internet of Things. So other participants, kindly mute your mic. Some background noise is coming. So I request all. Okay, thank you. So as Internet of Things or IoT is one of the key areas of research. And if we discuss about the latest technologies or latest implementations related to IoT, you might have heard about IoE, that is Internet of Everything, in which we are working with different types of sensors, different types of open source boards. You might have seen in current scenario, nowadays, we are not only in the world of IoT, but we are in the world of IoE, that is Internet of Everything. What is Internet of Everything? In our surrounding, we are having lots of devices, lots of gadgets, CCTVs, webcams, smart gadgets, routers, FASTag, smart watches, health gadgets, smart ambulances, so many things you might have seen in current scenario. But where is the major issue for a researcher? In research domain, if some researcher or research scholar or some academician want to work on IoT, then it's very difficult to purchase actual sensors. It's very costly affair to create an IoT scenario. For example, I'm working on congestion control or effective routing technique or security algorithm, or my area of research is like blockchain implementation in IoT. Then the question comes where to implement it, from where I will get those devices. Should I purchase some actual FASTags? For example, we want to implement security algorithm in FASTag, which we use in vehicles. Then how to integrate it? If somebody want to work on that scenario, who will give that particular access of towers or servers, FASTag servers or mobile controllers? Even we can't handle, even we can't customize our actual Android device also. We can only play with some apps which are available in Google Play Store. If I want to implement some algorithm, some technique in my device, then how to do it? For such type of issues in which there are some particular hardware is involved, there are some particular chips involved, we work on simulation part. Simulation part or integration of specialized libraries for IoT implementation. So in this session, we will see which are those platforms. If I want to work with some protocols which are required for IoT implementation, then how to do it. And most of the implementations will be in practical hands-on mode. So first of all, we'll see which are those prominent platforms under open source distribution for IoT programming. If I am a researcher, if I want to implement an algorithm related to blockchain or distributed computing or dynamic cryptography or quantum computing in IoT, then how to do it? Obviously, nobody will give me access to mobile towers. Nobody will give me access to actual FASTag servers. But I want to see what will be the scenario of quantum computing with IoT or dynamic hash based cryptography with current FASTag implementation. For these scenarios, we use open source platforms. However, we are using so many platforms from more than a decade. I think many of the participants might be aware with some platforms like NS2, NS3, Glomosim, Walnet, Vailenta. Many of these are proprietary. For wireless programming, for IoT programming, sometimes we use MATLAB also. But what is major issue with MATLAB or proprietary software? We have to purchase, or many times you might have seen that scholars or practitioners keep its pirated copy, and that creates another set of problems. So rather than moving to pirated copy or any particular proprietary software, we should focus on specialized platforms for IoT programming, which are completely free. And as you can see here, Contiki is one of that. Contiki operating system, Open IoT, Zeta JS. Okay. And one more thing, all of these platforms are completely free and dedicated to IoT. Why we are discussing about specialized platforms for IoT only? Because what we do or what scholars do in general, they use NS2 or NS3 or GNS3 or Vailenta, which are for wireless sensor networks or which are for mobile ad hoc networks. And then we try to implement, then we try to integrate some particular code which will give us the flavor of IoT. But rather than customization of WSN simulators, we can use specialized simulators which are only for IoT or IOV, Internet of Vehicles. You might have seen many scholars work on VANET. Earlier, we were working on VANET, Vehicular Ad Hoc Networks. Okay. And if VANET is to be integrated with IoT, then it becomes IOV, Internet of Vehicles. Okay. So, what is the traditional process with scholars? They try to customize NS2 or NS3 or GNS with some code customization, and it will give us the similar results. Why to take similar results? Why to customize WSN platform when we are having a specialized platform? Thousands of specialized platforms are available which are for IoT programming. And you can see Cup Carbon is one of that. Cup Carbon. Is it visible to all participants? Kindly confirm in chat. Cup Carbon for IoT programming, and it is integrated with those protocols, with those functionalities which we need in Internet of Vehicles, completely free and open source. Okay, so you can see this Cup Carbon. If you are interested or if you are working in vehicular ad hoc networks, but not VANET, vehicular networks on Internet of Things. Okay, so you can see it is completely free and open source, and It is having interfacing with Python, and you can see MQTT protocol. What is MQTT protocol? MQTT is this specialized protocol which we use in IoT. In traditional wireless network programming, which protocols we use? TCP, UDP, or some protocols related to WSN technology or VANET technology. In case of IoT, in most of the scenarios, MQTT or COAP is used. MQTT, that is message queuing telemetry transport. COAP, that is constraint application protocol. And both of these protocols are not available in NS2. Both of these protocols are not available in wireless simulators. So if we are working in IoT, then we must work on IoT based platforms rather than WSN simulators. Okay, so you can see this. Even Android interfacing can be done. We can connect our mobile phone with this particular simulator. In this scenario, we can capture data from our mobile phone like voice or signal. So in real time, my mobile phone will act as a sensor. It will fetch data from its surrounding. It will be processed within cup carbon. Okay, so this is one of the technology, cup carbon. In same way, we can use IoTVT, DSA, Zeta, okay, and flowhub.io. All of these are directly available without any cost. And most of these platforms are easily programmable, very easily programmable in JavaScript, in Python, and so many source code snippets are available. So flow-based programming for JavaScript. So if you are comfortable in HTML, JavaScript, we can work on these platforms. Okay. So hundreds of platforms are available in open source distribution for visual programming of IoT. If I'm working on some algorithm related to smart ambulance, related to telemedicine, then we can use these platforms, these software for programming of our IoT implementation. Okay. Now, so as hundreds of platforms available nowadays, we have already told, but so obviously it is not possible to cover each and every protocol, each and every platform in details. Okay, so in this session we will focus on one platform that is very popular and high performance, that is Node.js and Node-RED. Now we will perform some implementations in Node.js, Node-RED platform, which is dedicated for Internet of Things. Okay, so I'm opening this Node-RED. Okay, this is IoT-based platform for simulation of different algorithms. Okay, Node.js, Node-RED. What is Node-RED? Node-RED is a package onto Node.js. So I'm opening its official website and I will show you its live demo. In real-time demonstration, we will see some examples like fetching weather forecasting data, how to fetch some particular data from Wi-Fi signals, from Wi-Fi routers. So we will see it now. Node-RED, you can see this. Programming tool for hardware devices and one of the best platform for Internet of Things. Is it visible to all of you? Kindly write in chat. Kindly confirm. Is it visible and audible clearly to all of you?
Yes, sir.
Okay. So
Yes,
you can
sir.
okay. So you can see Node-RED This is very high performance platform for IoT programming, for simulation of IoT environment. Its backend is JavaScript. And one more thing is there. When task comes on programming, then many times you might have seen that people get fear of it, that we are not comfortable in programming, specifically for those who have worked on NS2, NS3. Okay, so earlier traditional programming platforms were very, very complex. So many lines of code we had to write. But you will be surprised to know that using Node-RED platform, there is no need to write even a single line of code. Or if we want to write some script, in 2 to 3 lines of code, it can be done. So if we compare it with traditional platforms, if one script we are writing in NS2 and NS3 in 100 lines of code, same script can be replaced in Node-RED in 2 to 3 lines of code. Okay, why? Because Node-RED is that platform which supports flow-based programming, design-based programming. What is design-based programming? In case of Node-RED or similar platforms which I have shown you in presentation screenshots, in these we create only diagram of the process. We only create DFD, data flow diagram. Backend coding is automatically done by the platform itself. I'm repeating this point. Each and everything is already available. Only we have to create a design. Only we have to work on drag and drop and connections, and everything will be done. If any person is not comfortable in programming, they can also work on it. And you can see that how many modules are there. More than 2 lakh modules are available in Node.js. Okay, so Node.js is at backend of Node-RED, and using Node-RED we can program any IoT environment, any IoT scenario we can deploy. Now we will see how to work. So obviously, so if we are discussing so many things about this platform, about flow-based programming of IoT in open source distribution, then how to work on that? Can we do it on Raspberry Pi? Can we work on Arduino board or Android? So you can see, you can install it on open source hardware also. Android, Arduino, BeagleBone, Raspberry Pi. If you want to work on laptop, no issue. In Docker, it will be available. Okay, directly you can install Node.js, and onto Node.js, we work on Node-RED. And third part is cloud. We can work on cloud also. So when we integrate IoT with cloud, then what happens? It becomes cloud of things. When each and everything is connected, cloud, IoT, devices, sensors, then it becomes Internet of everything. So cloud connectivity, it means for COT, cloud of things. For traditional or classical IoT, we can work, and you can see that IBM Cloud, Sense Technique, Fred, Azure. Now we will start the implementation part. I will show you its demonstration. So you can see that we can take any of these. So for simplicity, for explanation in easy way, I am taking a cloud service because it is an online session, and that's why I'm taking a cloud-based application, cloud-based deployment of Node-RED, so that you can see, and you can also do it later on. Okay, so now we will see how to implement IoT scenario on Node-RED, which is on cloud. Okay, so this. I'm not taking IBM Cloud, Amazon, or Microsoft Azure. Why? because you might be knowing that in free tier of IBM, Amazon or Azure, we have to link our credit card. We have to link our card credentials. If we are using FRED cloud, it is also free service, Fred Sense technique. Using this platform, we can create any IoT scenario and there is no need to link any credit or debit card. So you can see that this is the working panel of Node-RED. Is this visible to all of you? Kindly confirm. This is the dashboard of IoT platform, that is Node-RED, completely free and open source. You can see that protocols are also given, MQTT in, MQTT out. Is this visible to all? Kindly confirm in chat. If we want to work on, if we want to work on some data analytics, so Twitter in, Twitter out. For example, we are getting data from sensors. We want to analyze it, okay, and we want to plot it. We can do it. If we want to fetch data from Twitter, it can be done. And file handling, TCP. Now we will see how to work on that. In this platform, we will create only diagram. Only flow process will be designed. Okay, so this left hand side is having a palette of different operations. What I want to do, whether I want to work on MQTT in or MQTT out. Okay, MQTT is the protocol of IoT. If I want to integrate COAP, that can also be integrated. If I want to use any other protocol, it can be integrated. Okay, WebSocket in, WebSocket out, everything is available. Now we will check very simple application. Okay, so this is inject. So simply drag. For output on console, for output on screen, we use this debug. So you can see that I'm not writing even a single line of code. I'm simply dragging some components. And after that, now if I connect it, only this is the basic part, very simple part. After that, we will use protocol of IoT. Timestamp, this is the connector. I am connecting it with output. Okay, so you can see that this is the diagram, and we can deploy. At top right corner, you can see this deploy button is available, and on click of this, it will be deployed. And here on pressing this, you can see that this is the output. Okay, only timestamp we have fetched. Again, anything we can specify. Okay, so up to now we have not integrated any protocol or any service related to IoT. Now we will see how to work on IoT protocol in MQTT integration, how to associate IoT protocol with Node-RED. Okay, so I'm clearing this timestamp. Okay, this. So first of all, I will tell you about, so all of these screenshots I have already taken, which I will cover. Okay, so now we will discuss about this protocol. As we are already aware, all of us are aware that in case of IoT, what happens, or what is the major theme, that is device to device communication, gadget to gadget communication. For example, I am working on a research project that is related to smart home automation or smart office automation. In smart office automation, in smart home automation, I want to connect my LED, washing machine, AC, my vehicle, each and every object I want to control from my mobile phone. For device to device communication in IoT, a special protocol is used that is known as MQTT, which is known as message queuing telemetry transport. You might have seen that in vehicles, in cars, we use a particular fast tag. As soon as that fast tag comes near to that toll plaza or comes near to that particular server or sensor, automatically money is deducted. What is that? How it is possible that HTTP is implemented in uh, FastTag? We can't install HTTP application. We can't install FTP. We can't work on Telnet in a small chip. In a SIM card, we can't install any HTTP or FTP based application. So, which is that protocol which is providing device to device communication? Which is that protocol which is providing chip to chip communication? MQTT is that protocol. Sensors, all smart gadgets, they communicate via MQTT. Okay. In case of HTTP, what we do, there is request response. We request some particular information and we receive some response. Okay. In case of MQTT, we do not use the term request response. In MQTT, we use the term subscribe and publish. If I am getting data, if for example, I am having one sensor, in that sensor, I want to get data. It means subscribe. I am subscribing some service. If from that sensor I am sending data, it means publish. In HTTP, we use request response. In case of HTTP or traditional web servers, traditional web applications, we use the term server. In case of IoT, we never use the term server. In IoT programming, in IoT scenarios, we use the term broker. So if I want to control my LED washing machine, my install MQTT broker. And with that MQTT broker, I will communicate with my devices. I can't interact with any other.
WebEx Assistant is enabled to save audio highlights.
Okay, so MQTT broker will provide me connectivity with different chips. And which is that broker? Mosquito. So you can see that Mosquito. Thousands of brokers available. Mosquito.org. Rabbit MQ. Thousands of free brokers are available for IoT programming. So you can see this is Rabbit MQTT. Is it visible to all? This is open source message broker. This is Mosquito, completely free and open source. So if I want to make my mobile phone IoT server or IoT broker, then I will install Mosquito in my phone, Mosquito in my laptop. If I'm downloading and installing Mosquito in my laptop, then my laptop will become IoT server. And from my laptop, I can control my bike. I can switch on any LED. Okay, so if my LED is having sensor, if my TV is having sensor, I can connect that TV with my laptop via MQTT, via Mosquito. Or Rabbit MQTT or Hive MQTT. There are so many platforms in free distribution. Okay, so you can see that we can directly install it. And Hive MQ. Now we will see how to connect these platforms with Node.js, with Node-RED. So you can see that in this, what is Hive MQ is MQTT broker, and using this MQTT broker, if this MQTT broker is installed in a laptop or mobile phone, then from that mobile we can communicate with the satellite, we can communicate with car or any logistic or any drone. So you can see that this is a drone, some vehicle, washing machine, home appliance, any vehicle, connect any device. So for device to device communication, for chip to chip communication, we must be having a particular device in which we install MQTT broker, so that from that device we can control all other devices. Is this point clear to all of you? Up to this point, is it clear to all? Kindly confirm.
Yes, sir.
Okay, so MQTT, so you can relate it with a server. Okay, in web application we call it as server. In IoT we don't use the term server, we will use the term broker. If this broker is in my mobile phone, then my mobile will control all other devices. Even from my mobile I can interface with my FASTag, with my LED, with washing machine, with some smartwatch or any family member remotely also. Okay, so now we will see how to do it. So this is Node.js. Okay, Node.js, Node-RED platform. Node-RED is installed onto Node.js, and you can see this MQTT in, MQTT out. Whatever results we are having, if I want to send to a particular device, then we will use it, MQTT. Okay, so you can see this MQTT out. If I want to receive data from some sensor, then we use MQTT in. Okay, and from where we want to get data. So first of all, I will show you very simple interfacing, and we'll demonstrate it on a cloud service. So MQTT out, this we have dragged. For example, some data we want to capture from this. Okay, this is the timestamp, we are connecting it. Okay, what is this MQTT? In this MQTT I will set the properties of my broker, IoT broker, and this is the broker that I am using now, that is Cloud MQTT. It is also free. It is also freely available for IoT programming, that is Cloud MQTT. It means from anywhere we can control our devices. If you are having a center locking system, so you might have seen we are having a particular range. In that particular range, we have to press the button. Okay, we have to press the key. Only then we are able to on or off that particular vehicle. Okay, doors of that particular vehicle. But if you are using Cloud MQTT or cloud-based platform for MQTT, then even from 500 kilometers away, you can use your center locking system because it is on internet. Okay, so you can see that you can create a free account on Cloud MQTT, and it will give you the credentials. So simply you can create a new instance, and its username password will be given, on which port it is working, and that setting you can give. Okay, any specific topic you can specify. For example, this security, what is username password? This is same username password, and which are the messages, and after that device status. Done. And if done. Okay. So whatever data, whatever programming I'm doing here, for example, some device is connected here, some particular sensor I have taken here. Okay. So I will in next demonstration, I will take an example of weather forecasting, weather data, okay, climatic data analysis, and then sending it to cloud. Okay. Sending it to IoT. So up to till now, we are checking only this part just for beginning, just for basic understanding. So you can see that deploy. And now it is connected. Now this status is connected, and on click of this, you will see in WebSocket UI. Okay, so this is, so whatever messages I am sending from here, it will be received. Okay, so this platform we will use for interfacing. So you can see that this, and after that, so you can see this device status. This is device status, whatever signal I'm sending. So again, I'm clicking here, and again device status. It means whatever signals I'm sending from Node-RED platform, it is sending to MQTT broker, and with MQTT broker my FASTag is connected. So this signal will move to my FASTag, or this signal will move to my AC or refrigerator, whatever it is. Okay, so this MQTT will act in between. This is my front end. Okay, user or programmer or researcher will operate only this diagram. Whatever output will be there, whatever signal is there, it will move to MQTT, and from MQTT further connectivity we can perform. What is meaning of further connectivity? So you can see in settings, if I'm having an LED, okay, in that particular LED I want to connect. So what I will do, in the settings of that LED, I will put this server name, this username, this password, and port number. So what will happen? From this platform, I will send signals to cloud MQTT, that is IoT broker. From MQTT broker, data or signal will move to that particular device. Okay, whether that is central locking system or washing machine or whatever it is. Is this point clear to all of you? Kindly confirm. Up to this point, is it clear? By which way MQTT can be placed in between as a server. Now I'm covering another part. So you can see that in this left hand side part, there are so many palettes. Okay, so many options available. I want to work on weather forecasting. I want to work on weather prediction using Node-RED. So for that implementation, we will have to customize this platform. Customize means I can add another set of blocks. So many blocks are available for Node.js platform in npmjs.com. What is npm.js? npm.js is the repository of thousands of packages which we can use for IoT programming, for cloud programming, for blockchain, for quantum computing, for WhatsApp interfacing. If I want to, if I'm working on a research project for farmers, for agriculture, that some quality of the agriculture land is getting analyzed via sensors, and if some parameter is above or below threshold, that signal will move to the WhatsApp of farmer. Okay, or that signal will move to the WhatsApp number of agricultural scientist. So you can see WhatsApp. All of these are completely free. WeChat. So all plugins are completely free here. Nowadays, Node.js is giving very close competition to Python. Many times we think that for each and everything Python is sufficient. Yes, definitely Python is very powerful. We can do everything in Python. But nowadays, Node platform or Node services are giving very close competition to Python. Okay, each and everything is available in npm. In Python, we use PyPy. You might have used pypy.org. If I want to install something, so pip install TensorFlow, pip install Raspberry Pi, pip install this, pip install that. In case of Node services, we use npm. Npm install Facebook, npm install Arduino. For example, you are working in Raspberry Pi. So you can see so many services available, so many plugins available. If I want to work with weather forecasting, so open weather map, Google Map, okay, React Google Map. So if I want to work on such scenarios which are custom for my research work, which should be extended for our research work, then we have to install this platform in our system. For installation of this package, so you can see that, so whatever platform we need to install, whatever service we need to install, so this is npm I Google Maps. In same way, WhatsApp. Okay, so if I want to send some signals, some data related to climatic conditions, related to soil quality, so you can see npm I WhatsApp. Everything will be available. And Arduino. Okay, COAP protocol, Constraint Application Protocol, MQTT, interfacing with all services and protocols available. Okay, now we will see that part which we are discussing here, that is deployment of Node.js with our custom modules. So you can see that in my system I have installed Node.js. Okay, so master platform of Node.js you can install from nodejs.org. So what is the sequence? First of all, we install nodejs.org. Onto nodejs.org, we install Node-RED, and then we will be able to work with IoT programming. Okay, so you can see it is freely available, free and open source, very lightweight platform, but high performance. Okay, so you can see this version you can download, and after downloading of Node platform, you install npm I and Node-RED. Just this. Automatically your IoT platform will be enabled. After installation of Node-RED with npm I command, we run it. Now I will run Node-RED in my system in dedicated way. Okay, till now we have seen MQTT, this particular platform on cloud. Now we will run it on our own system. You can see that Node-RED services are getting activated. Okay, so we are opening this, and very soon we will get local IP address. On local IP address with port number of node red, we will create a scenario for weather forecasting, for analysis of weather conditions. Okay, so it is now getting activated, and very soon you will see that we will be having some modules related to WhatsApp, plotting charts, and open weather map. So you can see that now my server is running on this port number, this IP address and port number 127.0.0.1.1880. Okay, now I will open this in my browser. Okay, so this is my local node red, which is IoT platform, IoT programming platform. And you can see here, now scan Wi-Fi. In cloud, it was not available. In my system, I have installed it using npm I Wi-Fi. And you can see here some other modules, CouchDB. So NoSQL database. And this WhatsApp bot. If I want to connect my WhatsApp, so whatever data we are analyzing from sensors, I want to receive those signals in my WhatsApp group or in my WhatsApp number. Open weather map for weather forecasting. So we will discuss one by one. First of all, we will start connecting Wi-Fi with MQTT. Scan Wi-Fi. Wi-Fi scanner. From where I have installed it, I have taken it in npm.js. Simply search for scan Wi-Fi. Okay, so you can see node Wi-Fi scanner, Wi-Fi controller. Thousands of services available here. So Wi-Fi scanner I have taken, and whatever signals I am taking from Wi-Fi, I want to send it to IoT broker. Simply connect it. Is this visible to all? Is this process? Wi-Fi scanner, and we are sending this output to MQTT, and this MQTT can be further connected to any device. Okay, and this is my inject. So you can see that I'm not writing any script, I'm not programming any code, I'm not writing any particular lines of code. Each and everything is drag and drop. And if I'm moving these blocks here and there, this connection retains, it will not be broken. Now, this MQTT settings I have already done. So device, okay, send to device, signal, done. And what is Wi-Fi scanner? First of all, I will show you from where it will scan Wi-Fi. This is my laptop. In my laptop, you can see that so many signals are coming. Okay, so many routers, so many hotspots are available. So all of these hotspots will be captured by Wi-Fi scanner. Okay, for just for demonstration, I'm showing that whatever routers, whatever hotspots are activated in surrounding of me, in surrounding of my laptop, these will be captured, and these data will be sent to MQTT. Okay, so done, and now deploy. So at one side, I will open this so that we can check these messages. Okay, deploy, and we will check if it is connected, and timestamp successfully injected. Okay. successfully injected. So successfully injected. So we can perform a loop also. Okay. So if I want to get output on screen, so for debug. So if you want to see output on screen, debug, deploy, and you will see here. This is Wi-Fi scanner, and you can see this on console also. These outputs will be visible. So you can see this Wi-Fi scan. This is console. And on Control C, you can see that. So you can see this is the output. So how many signals we are able to capture? So you can see this. This is GK. This is my hotspot. Nav 4G. This is Nav 4G. Okay. And another Virat Media, whatever it is. Okay. Is this visible? That on screen we are able to fetch it in this platform. What is MAC? What is signal level? Is this visible to all of you? That on screen we are able to get Wi-Fi signals from surrounding. Geo Fiber 4G. This. So now if I delete it and if I put it, if I place here MQTT out, so these signals we will check. Deploy, confirm deploy, and after that we will check it. So what is my service? I will check settings, details. So these credentials I will put here. These are the credentials. Okay. So soldier.cloud MQTT, and here again this, and after that security. In security, this is my username, and in password, this is my password, which I am taking from MQTT update. And now signal set, whatever it is, done, and deploy. After deploy, click here. Okay. And in WebSocket UI, you will see very soon it will be activated. Okay, timestamp. So at this point, we will start receiving data. And deploy. So simply by drag and drop, we will be able to capture that particular signal set. So in multiple instances. Okay. So is this point clear to all of you? How to create a diagram, how to create a flow diagram of IoT scenario? Very simple, very easy going, and without any scripting, we can work on that. Okay. Up to this point, is it clear to all of you? Kindly confirm. Are you getting the concepts, or speed, fast, low, you can suggest. Because of time constraint, I am covering the contents quickly, because I want to cover so many things. I want to tell so many services, so many modules, and that's why speed might be fast. Okay, but if I will cover it very slowly, then some contents may be skipped. So I want to cover many things in short time span. Now we will see how to work on weather forecasting or climatic condition based scenario. So you can see here at bottom left, I have installed Open Weather Map. Okay, Open Weather Map, and node which polls Open Weather Map and returns when change is detected. Okay, so you can see that this, I have dragged this particular block for output on screen, debug, inject. If I want to send this data to Twitter, to my Twitter account, I can drag Twitter, connect. One output will move to Twitter, second output will come on screen. Very simple. After timestamp inject, one output will move to Twitter, second on screen. Okay, so first we will deploy on screen, then we will deploy on Twitter also. Okay, Open Weather Map, double click, and it is asking for API key. Okay, so I will see Open Weather Map API key. Okay, when we work on some applications related to third-party applications, we have to use API keys. Okay, so Open Weather Map. I am searching for API keys, and you will see that in Open Weather Map, this is the mail. So when you will create account on Open Weather Map, you will get these keys. Why this key will be used? Because using this particular key, data will be fetched. Without keys, we can't fetch any third-party data. If I want to fetch data from FastTag, I need keys or authentication. So this key I will use in my platform. Simply paste here, copy paste. Now for which particular city I want to fetch the climatic condition or weather. Patiala, India, climate, just for demonstration, done. And you can see that on a single click it will be done. And now I'm deploying it, deploy, timestamp, and we will see the output. Okay, so climate, and successfully injected. So it will take some time, and this particular data will be displayed. Okay, so you can see that at bottom. Is this visible to all of you? Today is a clear sky. Today is clear sky in Patiala. Temperature and wind direction, wind speed, weather is this. Is this correct or not? Is it correct? Humidity, temperature, clear sky. So this output, is this clear to, is this visible to all of you? This output we have fetched. Are you getting this output? Using Open Weather Map. Is this visible to all? Kindly confirm in chat. So if I want to change city, For example, Shimla, okay, or Kasoli, done. Key we have already deployed. Key we have already entered. Okay, and deploy, and after that inject timestamp. After injection of that timestamp, we will get new output. So this is the result. So using this block, climate, which is inbuilt. If I want to make some conditions, if I want to send this data to WhatsApp or to any Twitter account, it can be done, it can be sent. Okay, so Twitter out, send tweets and direct messages. So Twitter out, connect. Which Twitter? So Twitter credentials we can take, API key, API secret. Now I will connect with my Twitter credentials, so that one data will move on screen, second data will move on Twitter, another same data set we can send on a particular tower, same data we can transmit on a particular mobile phone, on different gadgets. So this is Twitter developer account. To take Twitter tokens, to connect Twitter with IoT or sensors, we need to get tokens. So previously we have taken tokens from Open Weather Map. Now we will take tokens from Twitter. So these are the tokens. If I want to interface Twitter account with my sensor data, so copy API key, okay, and I will paste here this API secret key, paste here, access token, regenerate, and copy, paste, copy. So it means what I'm doing now, I'm taking Twitter credentials so that I can connect with my Twitter account. Done. So if I want to send data on WhatsApp also, it can be dragged. In that case, that particular mobile number, that particular mobile phone, or that particular device should scan a particular QR code. Okay, so now we will deploy this. Deploy, and we will click on this. Okay, now you can see that it is tweeting. It is written that tweeting. So that particular data will come here. Okay, so click here, tweeting, and here this message and tweeting. So at one point it is sending data to Twitter, at second point it is sending data on screen from this Open Weather Map library. Okay, Node-RED. If we want to interface it with feed parser, if we want to use a feed parser, it can be taken. Feed parser means from a particular live channel, we want to take some particular data for feed parser. From some RSS data, atom feed data, we want to capture some particular data set. Is this point clear to all of you? Up to now, whatever we have covered in Node.js, is this clear to all of you?
Yes, sir.
And how much it is looking, how much it is looking easy or difficult to work with? Is this clear? Okay. Now we will cover another platform. We will cover another service for IoT programming, that is Contiki. Contiki operating system. So very quickly we will be covering this part. Contiki operating system for IoT programming. Most of the protocols related to Contiki, related to IoT are available here. Okay, most of the IoT based techniques, IoT based protocols are already available in Contiki new generation simulator. So if we want to simulate some IoT process, some IoE process, no need to take NS2, NS3 or any other traditional wireless simulator. We should go for high performance dedicated platform, that is Contiki operating system. Okay, what is Contiki operating system? Contiki is a customized version of Ubuntu. Ubuntu operating system is customized with IoT protocols, and it is completely free and open source. And now very quickly I will start its demonstration. Okay. On VMware workstation, I will execute this service, this particular simulator, and you will see that how much it is powerful. So now I am starting this virtual machine, and in this Contiki operating system, you will see that most of the things, most of the implementations will be in GUI mode, and very powerful output, very effective output will be there. Automatically graphs will be generated. In traditional simulators, what we do, we execute it. After execution of that particular scenario, we collect log file. After after pre-processing of log files, after analyzing those log files, we use XGraph or Excel for plotting. In case of Contiki operating system, Contiki CUSA, there is no need to create a graph. All graphs are automatically generated, like latency, energy optimization, power optimization, execution time. All of the graphs will be generated automatically. So user is the password of Contiki operating system by default, and this is the scenario. This is Contiki operating system for IoT programming. So you can see this on terminal. I will start this simulator. Okay, so in Contiki CUSA. So I'm showing you this part. So this particular presentation I have already prepared, but I'm showing you everything in real-time demonstration mode. Okay. Now I'm running this simulator, and I will share this presentation to all of you so that you can work on that. And very easy, these screenshots I have already taken, which will be given to all participants so that you can follow and you can customize these codes. Backend coding of Contiki is in C language. Okay. So very soon its simulator will be loaded. Okay, so you can see that I'm opening Contiki Kuza platform for IoT programming, free and open source, and in complete GUI mode we can work. So you can see this Contiki network simulator for IoT programming, file, new simulation. Which medium I want to use? UDGM, node radio traffic. What is random seed? So my IoT, anything, my IoT simulation. Okay, create. And so you can see that. And this is the working area. Now modes. In IoT, we call sensor nodes as modes. Okay, in wireless network, we call as wireless node. In case of IoT, we use the term mode. Okay, create new mode. Which type? So you can see that different types of modes are available. In other simulators, this feature is not available, that we can take custom nodes. Okay, so any mode we can take, sky mode. And which particular protocol I want to work with? IPv6. Okay, on IPv6 UDP RPL, and I want to take one receiver. It means one receiver mode, compile. So this is C code. I can change this particular C code. If I'm working on quantum computing or quantum cryptography, I can insert my code, my function of that particular implementation in this file, and then I will compile it, create. How many modes? One mode. Add. Now this one mode is added. Add modes. Create new mode. Now I will take some sender modes. Okay. So the sender. So unicast sender. Compile. So if I want to use ant colony optimization, genetic algorithm, or honeybee approach, or meta heuristic approach, I will write that code in this, and then create 10 modes for sender. Now one is receiver and other modes are senders. Okay, these are sender modes. Now we will see. Okay, view what I want to display, radio traffic. What I want to see, other things. Okay, radio environment. This is radio environment. Now you can see that I can see range of each and every mode. So this one mode can send data to these modes in green area. 2 is out of range. So either I will have to take it closer to 2 if I want to send data to 2. Okay, what is range of 5? If I'm working on some shortest path algorithm or honeybee approach, ant colony, so we can work in this particular scenario. LED and log output, mode output, code. Now start, and you will see that radio traffic will be activated. Okay, so is this visible to all of you? We can see very easily which node is sending data to which other node. Is this visible to all? Free and open source.
Yes, sir. Visible.
Okay. And how much? And now, as I was saying, that no need to create graph. Each and everything will be done automatically. Now you can see that. Right click, mode tools for sky, collect view. If I want to connect some sensor, so you can see that serial socket, client server, MSP CLI. If I command, I want to send some particular signal or some particular instruction. What is TX RX rate? Okay, I want to change transmission and receiving. If I want to change transmission and receiving ratio, okay. So currently it is 100% okay, but we can modify it. Now I want to see its output. What is output? Collect view. What is the graphical view of this simulation? Collect view we have activated, and it will start collecting the data. So you can see that sensor map and network graph. In sensors, as soon as data will be taken, so start collect. I can attach actual sensors also. Okay, start collect. And I want to see network analysis, by which way some particular nodes are working. So if we run it 2 to 3 minutes, then it will start capturing data and this particular scenario will be filled. Okay, send command to nodes, start collect. So movement we can check, and you can see that this data is flowing, and in this view we can check. Okay, pause and start. So collect view. And it will start collecting data. So in real time, we can attach some sensors, and we will be having very good results. So each and every parameter will be calculated automatically: power consumption, sensors, neighbor count, how many packets were lost, how many packets were received, latency, routing metric, okay, execution time. Everything will be calculated automatically in few minutes. Okay, so if we keep it running for some time, then we will be able to capture all the data. Okay, how much it is looking easy or difficult to work with? So you can see in if I want to add some new modes, add modes, create new mode type. So Z1 mode, ESB mode. If I want to see architecture or configuration of this mode, so it will be available. Mode information. Okay, mode information. So its complete board will be available. I can see its architecture. What is the firmware associated with this particular mode? Okay, so you can explore very easy and effective platform for IoT programming. Okay, I'm sharing this presentation to all participants. Both of these presentations I'm sharing, and I will upload it on a cloud link so that you can work. If any participant wish to communicate, you can unmute or you can write your query in chat. Meanwhile, I'm uploading this presentation on cloud. Any query from participants?
Hello, good evening, sir.
Yeah, good evening, ma'am.
Sir, I just want to ask that firstly, you were using Fred, right?
Yes, ma'am.
Fred and Node-RED are same.
Ma'am, Fred is the name of cloud. Fred Sense Technique is the cloud, and onto that cloud, Node-RED is installed.
Okay, okay, sir.
Okay, so so you can relate it like Amazon Web Service. AWS is cloud, and onto AWS, what we are doing.
Okay, okay, sir. And moreover, sir, when you have deployed MQTT, then
Yes, ma'am.
in that platform, it was showing MQTT in and MQTT out. Sir,
Yes, ma'am.
what's the difference between both?
Ma'am, MQTT in means we want to receive data input. Okay, we want to receive data in MQTT broker. If we want to send data from MQTT broker to another chip, to another gadget, then we will use MQTT out.
And each and every protocol we are using in Thread, sir, they need to be downloaded from every time they need
Yes.
to download it.
No, only once we have to download, and after that it will be available forever. Only once we have to prepare our application.
Okay, sir. Okay. Thank you so much, sir. It was very wonderful presentation.
Thank you, ma'am. I'm sharing this presentation to all of you. Any other participant who wish to communicate, you can unmute. And I'm giving you link of the presentation. Any other? If you have any query, any doubt, any suggestion, most welcome. If you want to suggest anything, you are most welcome. If you have any query, you can unmute.
Sir, good afternoon, sir.
Yeah, good afternoon, sir.
A very excellent practical session which we learned, sir, because very, very useful for us. I need your contact number and your mail ID, sir, please, sir.
Yes, sir. I'm sending the presentation, and in these presentations, you will get the details.
Thank you so much, sir.
Okay. So, dear participants, link of the presentation I have shared in chat. So, kindly confirm, are you able to download? So, simply click on this link and download. It is a zip file. When you will unzip it, there are two files, two presentations in this zip. Kindly confirm whether you are able to download or not. Whether this file is getting downloaded, kindly confirm.
Yes, we can download, sir. It's getting downloaded.
Yes, sir. It is downloaded.
Okay, so it is a zip file. Simply extract. There are two presentations, and you can keep it. Any other query from participants? Any other point of discussion? As ma'am has told. Yes, ma'am. Good evening, please.
Yeah, I'm Dr. M. Sugasni from Tamil Nadu.
Yes, ma'am. Good afternoon.
Sir, can we use a Fedora for the same process what you have did in Node.js?
Yeah, definitely, ma'am. Node.js is cross-platform. Anywhere, even in Fedora, Windows, or you can use even Mac also. It is cross-platform. Anywhere you can use it. Even on Android also you can do it.
So already I have learned from your this workshop that Kuja simulator.
Yes, ma'am. Kuja.
Can we have that?
Yes, ma'am. That can also be deployed on multiple platforms. And
what is the main difference there? What is the main difference?
Ma'am, as far as Contiki Kuja is concerned, it is only for network programming, IoT. But in Node.js, you can do anything. Okay, Contiki Kuja is for IoT programming, for network programming. If you want to do data science, machine learning, deep learning, like Python, quantum computing, blockchain, so Node.js, Node-RED is general purpose. That is customizable.
Okay. Thank you so much, sir. Your presentation is very nice and it's a real-time example. We have learned a lot. Thank you so much, and thank you for all the organizers. Did the presentation very well for a week. Thank you, sir.
Thank you.
Sir,
yes, ma'am.
One thing more. Can we embed security also in this?
Yeah, definitely. If
for
you want
network
to,
security.
Yeah, definitely. Contiki Kuja is not only for IoT, for general purpose wireless networks also it can be used. So backend C code can be customized. So you can take C code from GitHub related to security, related to dynamic cryptography or SHA algorithm, different hash approaches. We can insert that code.
Sir, actually, I want to embed the security for SDN. For software-defined networks.
Okay. Yeah, definitely. SDN you can use. So
Okay.
in Mininet you can integrate it.
Okay, okay, sir. Thank you so much. Sir, can you share your ID, mail ID?
Yes, ma'am. It's available in the presentations which I have shared just now.
Thank you so much, sir.
Thank you so much, sir, for giving the wonderful presentation, and our participants also appreciated you for the wonderful session.
Thank you, ma'am. Thank you to all participants.
Sir, everybody is writing in the chat box that it was a nice presentation and they get benefited from your presentation.
Thank you, ma'am.
So, sir, we are reaching to the concluding of this FDP. So you can stop sharing your screen.
Okay, ma'am. Okay, ma'am. Is it okay, ma'am?
Yes, sir.
Okay.
So thank you, dear participants. And wonderfully, we reached successfully to the last session of this FDP. We are doing the validatory session. Our head of the department, Dr. Ranjit Kaur, has joined us. Our Dean Faculty of Engineering, Dr. Manjeet Singh Pathar, is with us. Our faculty members are also with us. If possible, can you switch on their videos? I request the dignitaries to switch on their videos. Thank you so much. I request Dr. Ranjit Kaur kindly share his valuable words with the participants as we are reaching to the end of the session.
Thank you, Dr. Richa. And I thanks all the participants for their participation in the FDP, and Dr. Gaurav Kumar, expert of the session. So as we are ending this FDP, so we are here for the validatory function of this FDP. I congratulate to all of you for your participation in this FDP, and I hope whatever the expert lectures has been delivered in this FDP will be beneficial to all of you. And definitely you have gained something related to Internet of Things, because I have seen most of the experts have enlightened us about the Internet of Things, how it can improve our everyday life, how we can work smarter and live smarter with the help of Internet of Things. And I want to thank the organizers of this FDP, Dr. Richa, she is the coordinator, and Dr. Sonia is the co-coordinator. So I congratulate to them for the successful organization of this FDP. And again, I thanks all the participants. And one thing more, I want to announce that we are holding one international conference in December. So previously date was 8th December. Now we have changed it to 14th December due to some issues. So I request all the participants so kindly contribute some research paper in the conference. So I hope that this association will work a long way with all the participants and all the experts. And I again thanks all the participants and the experts and the organizers.
Thank you so much, ma'am, for your kind words. Dr. Pathar is with us. Sir, can you unmute and share your valuable words with us?
Okay, good evening, everybody. So, first of all, I congratulate the organizers of Punjab University Electronics Department and AICT for such a wonderful and successful short-term program. And I'm very thankful to the speakers. They really shared their knowledge and views on the topic. And I hope that all the participants must have benefited from this program. And really some of them, I think, will take this topic seriously and do something wonderful in this. So I congratulate again all of you and my best wishes for the participants. Thank you.
Thank you so much, sir. Now I request the participants kindly unmute one by one and share your feedback with us.
Yes, good afternoon, madam. This is Sandip Kumar from Panimalar Engineering College, Chennai. From beginning of the Monday, that is from last Monday, we have some due to the cyclone and weather forecasting, we are on leave, and I am attending all the session, very useful for us, and the way you are organized and the all the presenter, that is overall guest lecture they are providing, everything is very good, madam. Very useful for all us. Okay, particularly the last session, Gaurav sir, is a very excellent practical session. So very useful for us. Thank you for organizer. Particularly Risha madam is supporting us for all the way. Thank you, madam, and thank you for the university also providing such a wonderful opportunity for everybody. Thank you, madam. Thank you.
Thank you so much, sir. It's only because of the department, sir. Any other participant who wants
My
to...
name is Doipan. Actually, I'm from Institute of Engineering Management, Kolkata. I attended this FDP. It was a wonderful, ma'am, organized by the organizer team. And from Monday, I've attended all the session, and it was an excellent. And from the speakers to all the lectures, so relevant, and based on the topic, it was a great learning, ma'am. Thank you. Thanks a lot.
Thank you so much, sir. Thank you so much. Anyone else who want to share? Any participant?
Hello, ma'am. This is Sonam Sharma from SRM Institute of Science and Technology, Delhi NCR campus. And I really enjoyed the FTP which was given by all. And the prominent point which I want to highlight is the practical sessions are very nice. You have included the practicals and hand-on experience for us, and also made us aware about the different technologies that are being upgrading in IoT day by day. So that was really a wonderful session, ma'am. Thanks a lot. Thanks to you also, ma'am.
Thank you so much, Sonam. Any other participant? So thank you so much for your feedback. Now I'm giving the formal vote of thanks. It was a great initiative by AICT Training and Learning Academy, ATAL, for spreading the technical knowledge and skill for the faculty of technical institutes all over the India. I'm thankful to the ATAL for giving us this opportunity to our Department of Electronics and Communication Engineering for conducting online FDP on Internet of Things 2021. This was first ATAL sponsored FDP in the department. Thanks to the ATAL for providing platform to the faculty members of technical institutes of the India to enhance their knowledge and skills. We got huge response of registrations as well as lot of compliments of arranging this online FDP. I'm very thankful and I feel hearty gratitude to all the resource persons for sharing their expertise in the area of IoT with us. During these 5 days, we have been fortunate to have a renowned identities from academia and the industry. My heartfelt thanks to Dr. Preeta Sharan for helping in arranging wonderful resource persons nationally as well as internationally. Ma'am, are you there? I think she is there. Dr. Preeta Sharan, are you there? Okay. So we are fortunate to thank the dedicated and well motivated team of our department. It's a teamwork. I'm not alone able to take the credit of the success of this FDP. First of all, I thank our worthy Vice Chancellor, Professor Arvind, who inspire us to conduct such type of programs. I thank to Dean Academic Affairs, Dr. Balbir Singh Sandhu. I thank to Associate Dean Research and Dean Faculty of Engineering, Dr. Manjeet Singh Patar. Next, thanks to all the administrators of Punjab University, Patiala. My hardcore thanks to Dr. Ranjit Kaur, head of the department, who is also Dean International Students, for unconditional support. I thank co-coordinator Dr. Sonia, who helped me day and night for this successful execution of the FDP. She is there. I request her to switch on her camera. Dr. Sonia. All the documents like quiz are being prepared by her. Thanks to Manpreet, thanks to Amandeep Singh, who helped me in arranging and managing the data. Also, I thank to the Mr. Manpreet Singh for supporting. Last but not least, I am thankful to all the participants for attending the FDP, and we are looking forward for future associations too. I'm sure that our university will continue to get significant provision for diverse group in the future. My best wishes and future success with you. Thank you so much. And there is one announcement, as our head of the department has announced that our department is organizing one international conference in the month of December, and its date is 14th December 2021. So I will sharing the brochure of the conference with you in the WhatsApp group. So please send your research papers there in the conference, and also share that brochure with your research scholars. So with these words, I take permission. Thank you so much for your participation and for your cooperation. Hope you enjoyed the FDP. And do send your feedbacks in the WhatsApp so that we can send it to the ATAL. Thank you so much.
What to send, ma'am?
Pardon, sir?
What you said that we have to send? What to send, ma'am?
Sir, you send your feedback on the WhatsApp or on the ATAL portal so that we can upload your feedbacks on the ATAL portal.
Ma'am, one more thing.
Yes, sir.
Sorry to ask this. Shall I get the attendance link for yesterday's afternoon session?
No,
since we have attended all the 5 days, yesterday by evening we couldn't able to fill the attendance form. Only except that all others are filled.
Sir, I have announced that don't worry about the attendance. If you are present in all the sessions, it will automatically come in my recordings. Don't worry.
Sure. Then okay, then nice. Thank you for the wonderful session.
Yes, any other queries? If you are
Ma'am,
satisfied.
pardon, ma'am. For feedback, do you share any link like that or?
Sir, no, you can drop me the message in WhatsApp, or there is a link on the ATAL portal as well. Feedback link is there. You can send your feedback there directly.
Okay. Thank you very much.